we're going to take a look. We have some extra work on the page here, but we're actually going to focus on this one here. So we have a swimming pool shaped in a square. Okay, so that's important. They've already given us some important information. With the area expressed as this algebraic expression, determine the algebraic expression of the length and width of the swimming pool. Okay, let's jump to the next page here. 4, 12, and 9. 4x squared plus 12x plus 9. Now, they gave us actually some important information there. They told us that this swimming pool is actually a square. Okay, so what that means to us is that the length, that means that the length and width are actually equal to each other, right? The square has to have a length and width that are equal. So what we need to figure out here is the length or the width. It doesn't have to matter which one, but we need to figure them out so that they are the same. So we're going to go through a factoring method. We'll use fearless factoring to do it. And in this factoring method, we got to make sure at the end that the factors are actually the same. So we should actually end up with something that's going to be a set of brackets squared. So we could technically use a perfect square trinomial. What that means is we should have something that looks like this. A squared plus 2ab plus b squared. That's some scenario where that if I square root the first term and the last term, that should give me the middle term. So we're going to, well, actually, you know what? We'll try that to start. And if it works, that's great. And then we'll use fearless factoring to get to the same answer. So I should be able to find the square root of first of these two. So 4x squared, the square root of it is 2x. Okay. And the square root of 9 is 3. Okay. We know that we should be able to go 2 times 2x times 3. And that should give us our 12x. And see if that's right. 2 times 2x is 4x times 3 is 12x. Perfect. That works. So since that's the case, we take the square root of this term, okay, and the factors of these, I didn't write it out, but if it is a perfect square trinomial, that means we can factor it really quickly by finding the square root of the first term, square root of the last term, and writing them as the first and the last term in the bracket squared. So what that means is we get 2x plus 3. That should be our answer. That works, right? Both of them are the same size. We'll use fearless factoring to find the exact same set of information. So let me see if I can just move a set of this over here. Oops, let's move this over. There we go. So we know those are equal. For fearless factoring, we're going to find the factors of 4. So 1 and 4, and 2 and 2, and of 9, 1 and 9, and 3 and 3. And we know the products need to add up. Some of the products got to be our middle term. Technically, there should be an x attached to each of these. Okay, since we know it has to be a square, we're going to do a little cheating in these columns here. That means that the factors should all be the same, which means these two columns should be our answers. We'll do this testing to make sure it works. 2 times 3 and 2 times 3 gives us 6x and 6x. You add them together, works out great, which means we have two sets of brackets. One of them has 2x and 2x is the first term. And the other ones have positive 3 and positive 3, which simplifies to this version. So we used two styles of factoring to get to the exact same answer. So we now know that we've confirmed by proof that 2x plus 3 squared is another way you can express the expression. And the side length must be 2x plus 3.